So this video is going to teach you how to balance equations using the brick method. You should have already watched Mr. Anderson's beginner guide to balancing equations, and so I'm going to reference that video in this one. This brick method is a good beginner method when you're first starting out, and it's similar to when Mr. Anderson was drawing the whole molecule on his video. Once you get comfortable with the brick method, you can graduate to the counting method, which is a little bit faster, and that's in the second video. So the first thing is when you look at equations, you're going to see what you see on the top row here. Ca plus O2 becomes CaO. And I always like to rewrite it like I did on the bottom row with spaces in front of the molecules because that's where I'm going to put my coefficients. So I'm giving myself room. So when you're doing the brick method, you basically draw out each molecule as a brick with all of the atoms that it contains. So for example, Ca, put it in a brick. O2, so I'm going to draw two O's in my brick. And then CaO in a brick. Similar to drawing out the molecules, but a little bit easier. Now, to make it balanced, you want to have the same number of each atom on each side of the equation. What I mean by sides is that there's kind of a split right here with the arrow from the reactants to the product. So you're just going to cross things out to see if they match up. So on the left side, I have one calcium, cross it out with one calcium, one oxygen with one oxygen, and I'm going to notice it's not balanced because there's an extra oxygen on the left side. I need to add an oxygen on the right side, and the right side only has one molecule, so there's only one brick I can draw. Now, I can't draw just an O. I have to draw an entire brick. Like Mr. Anderson said, you can't split up molecules. So that's going to fix my problem with my O, because it's balanced, but now I have too many calcium, Ca, on the right side. I need to add another brick to the left side. I don't want to add an O2 brick. I don't want more O's. I want another calcium, so this is the brick I'm going to want to add. Okay, now it's balanced, so I need to go back and add my coefficients. So there's 2 Ca bricks. There's only one OO or O2 brick. I don't need to write the coefficient, like Mr. Anderson said. We don't need to write ones. And there's 2 of these bricks. So the final equation would be 2Ca plus O2 makes 2CaO. Let's do another example. So once again, I rewrote the equation to have blanks to give myself room for the coefficients. Now this time, we're going to have some bigger bricks. So here we've got 2 Als, aluminum, and 3 Os. So that's a large brick. We've got 1 Al in this brick. And we've got 2 Os in this brick. How do I know what to switch into different bricks? This plus sign is separating molecules, right? So the Al, which is an atom, is separate from the O2 molecule. So now it's time to start crossing out to see if we're balanced. Remember, we're using the arrow between the reactants and the products as our split. So Al, O with O, O with O. Okay, so let's go ahead and balance this. I notice there's an extra aluminum or Al on the left side, so I'm going to need an extra brick on the right side. Now, I still have an extra oxygen on the left side, so I'm going to have to draw an oxygen on the right side. I wish I could draw one, but I can't. I have to draw an entire brick. Now I don't have enough oxygens on the left side, and I can't just add one. I have to add an entire brick. Okay. So now we've got extra stuff on the left side of the equation. That's okay. You kind of go back and forth when you're doing this type of problem. So I need at least 2 more Als. So let's go ahead and add those. That's 2 more bricks over here. And then I need another 2 oxygens, so I can add another brick over here. And now it's balanced. Everything's crossed out. So I've got 2 of these bricks. I've got 1, 2, 3, 4 of these. And I've got 1, 2, 3. So the final equation is 2 Al2O3 becomes 4 Al plus 3 O2s. Looks like 30, but it's not. It's O2. Let's do one last example. Okay, so once again, I've rewritten the equation to have blanks to fit my coefficients. So I'm going to start drawing my bricks. NOO, HHO, HNOOO, and NO. Okay, so if you're wondering how I knew, for example, to draw 2 O's in this brick, it's this 2 right here and 2 H's because of this 2. So I'm using the subscripts to help me figure out how many letters to put right in each brick. So let's start crossing out. N with N, there was 2 N's on the right side, doesn't matter which one we cross out. O with O, O with O, H with H, there's not another H to cross out, O with O. Okay, so let's start with the H's since that's all that's left on the left side. We need another H. There's only one brick on the right that has an H with it. Remember, this is our dividing line. So H, N, O, O, O. That fixes our hydrogen problem. Now we've got a lot of extra stuff on the right side. So let's go ahead and do the N, or nitrogen, first. There's only one brick on the left side that has a nitrogen, which is this one, and we need two more. So we're going to have to draw two more of those bricks. Okay, and now let's see if our O's match or if we have to do some more balancing. Nope, we're done. So 1, 2, 3, that's 3 of these bricks, 1, but we don't have to write ones, 2, and 1, which we don't have to write. So 3NO2 plus H2O makes 2 HNO3 plus NO. And we're done. So hopefully this brick video kind of helps you, and like I said, I recommend using the brick method when you get started, but if you find that it's too easy, then go ahead and graduate to the counting method, which is going to be in the other video.